Regents Review number 26. Question number 1 asks you to determine which interval has the greatest average speed. That's another way of saying rate of change. So the rate of change is found by subtracting the y values and then dividing that by the difference of the x values. So you have to be given an interval or a starting and end point. So for here, the first option is from the first to the second hour. So these two values here would give us a rate of change fraction of 110 minus 40 over 2 minus 1, which would give us 70 over 1. So an average rate of speed of 70 for that first hour. Now we're going to calculate that same values for the second, third, and fourth options. Second option is from the second to fourth hour. It's these values here. So 180 minus 110 over 4 minus 2, which gives us 70, but over 2 this time, which is an average rate of speed of only 35. And we can kind of tell that when we look here at the graph how steep this line is compared to the steepness of that second interval there. Right? It's not as sharp of an incline. The next options are from the 6th hour to the 8th hour. That would be these values here. So 350 minus 230 over 8 minus 6, which is 70, 50, 120 over 2, which is 60. And then the last one is from the 8th hour to the 10th hour. And that would give us 390 minus 350 over 10 minus 8, which is 40 over 2, which is only a speed of 20. So it looks like for us, the greatest average speed was between the first and second hour at 70 miles per hour. Question number 2 asks you, what property justifies the first step that makes this equation from here in red turn into this one here in blue, right? So if I look at these two expressions here, they're exactly the same, but what comes after this expression is a minus 9, and that is not written in the next step. So that means that this minus 9 disappeared, and the only way for a minus 9 to be removed is to use the inverse operation, which would be to add 9 to both sides. So that's why we no longer see it on the left, and that's why we now have a new 16 instead of a 7 on the right. So what happened was we used the addition property of equality to remove this minus 9 and add it to the constant on the right. Question number 3 asks you which of these 4 values satisfies this equation. So let's do a little distributing here. 7/3 x plus 7/3 times 9/28. So I'm going to take my calculator out and use my handy dandy fraction button to multiply 7/3 times 9/28. And it looks like we get 3/4. So we get 3/4 here. And now what I'm going to do is I'm going to multiply everything by 12. So I want to get rid of these fractions here. This one's going to be 3. And let's see, it looks like I'm going to get 28x plus 9 equals 20 times 12. 20 times 12 is 240. I'm going to subtract 9. 28x equals 231. Divide by 28. So I'm going to get 231 divided by 28. And 8.25. So number 1 is the right solution. Question number 4 asks us about the cost of manufacturing radios is given by this function here. C of R equals 5.25R plus 125, and they're asking us what the 5.25 best represents. Well, 5.25 is a coefficient of R. That means it's the rate of change, not the initial value, but the rate of change. So the startup cost would be the initial value. The profit would be this value here. The amount spent to manufacture each radio is the per number, or the rate. So this would be number 3. Question number 5. Cell phone company charges $60 a month for up to 1 gigabyte of data. The cost of additional data is 5 cents per megabyte. That's the rate of change. So the 60 is the initial fee, so that's the constant, and this 5 cents is the rate of change, so that's the coefficient. So we need 60 as a constant. That's happening here. So this is out, and this is out, and we need 5 cents as the coefficient, which these both have. And it sounds like you're going to pay both of these fees. So that means that we need to pay attention to this operation. And because you're going to pay $60 plus 5 cents per megabyte, that makes option 4 the correct choice. Question number 6 asks you to identify a linear function. Says it right there in the word. Linear function is a straight line. It's option number 1. Question number 7 asks you to solve for x. So that's 3/2 x minus, let's see what we're going to get here, 3/6, also known as 1/2, plus x equals 3. Let's see. So I've got some x's here that can be combined. So I'm going to put 2 halves here because it's single. So that gives me 5/2 x minus 1/2 equals 3. Add a half to both sides. So 5/2 x equals, I'm going to make this 6 halves. Plus 1/2 is 7 halves. And now I'm going to multiply by the reciprocal. And that gives me x is equal to 14/10, also known as 7/5. 7/5. Now what I'm going to do is I'm going to check that. Here's how I'm going to do that. I'm going to open my calculator here, and I'm going to type this fraction, 3/2, parentheses, and instead of an x, I'm going to type 7/5. So instead of an x, I'm going to put my solution in here, 7/5 minus 1/3. Close that, and then plus x, and again, x is 7/5. And I'm going to press enter, and in fact, 3 is equal to 3. Question number 8. This question has multiple parts, so let's take a look here. The function is defined by this graph here. And we want to find all the values of x, so we want to find the x coordinate values such that f of x is equal to 0. Now remember, this is just a fancy notation for y. So what points on this graph have a y value of 0? Or have a coordinate where y is 0, right? In order for your coordinate of y to be 0, you would have to be somewhere along this line here. So that means this one, and this point. 1, 2, 3, 4, 5, so that would be -5. That's my squiggly brace. It's not so pretty, but you get the idea since I'm listing numbers. +1 and +5. For each one of these x coordinates, the y coordinate would be 0. All right, let's take a look at the next question. Find the value of the function when x, then the input is 2. So when the x is 2, what's the y? When the x is 2, what's the y? Well, when x is 2, that's here. So keep going until you find your graph. So y would be 3. And now for the next question, if x is 6, which is here, go find your graph, and you had to go down 2. Find all values of x such that y is equal to -3. 1, 2, -3 is here. So anytime our graph touches that line of -3, then that's the value we're looking for. So here and here. So that's a list, -3, and when x is 0, right? So when x is -3 and when x is 0. Okay, let's close that brace. All right, last question. This function achieves a minimum value. That means the lowest it goes. What is the lowest number that it goes? Well, a minimum is a y value. -6. And it achieves that point when the x value is -1. Last question. Find 3 consecutive odd integers. So that's the first one. And next odd integer would be 2 more than that. And the next odd integer would be 4 more than the first. So we want 3 consecutive odd integers such that means here's your hint, 6 times the second. Well, 6 times the second is 6 times x plus 2, decreased minus twice the first. Twice the first is equal to 20 more than the sum of the second and the third. There's our translation. So over here we've got 6x plus 12 minus 2x equals 2x plus 26. So 4x plus 12 equals 2x plus 26. Subtract 2x from both sides. 2x plus 12 equals 26. Subtract 12 from both sides. 2x equals 14. So that means the first number is 7. But they want us to find all 3, so it's 7, 9, and 11. And that concludes Regents Review number 26.